Okay, so on this slide we're just going to go over the substitution method, which most of you should have seen before in Cal 1. First I just kind of want to talk about where it comes from. So you remember the chain rule. The chain rule is generally taking the derivative of a function that has another function inside of it. So we call those like f and g. So here the derivative of f composed with g is the derivative of the outside function times, still evaluated at the inside function, and then times the derivative of the inside function. So that's the chain rule. So we need a way to undo the chain rule, just as we're now learning how to integrate and sort of going backwards on taking derivatives. And so if we want to integrate f prime g of x, g prime of x, according to this, if we're just integrating both sides of this sort of up here, right, then that would just equal the integral of f of g of x prime. And this is actually not f, integral. So what that really is then is really just f of g of x plus c. According to the fundamental theorem of calculus, the integral of the derivative is just the original function. So this is what we're going to use when we start talking about the substitution method. The substitution method, if you start to notice in the notes, will replace this g of x equals our u, or sometimes you'll even see it written as u of x, and that's how you'll see the substitution method written. So here you see the official definition of the substitution method. So if f prime, capital prime of x is f of x, then if we integrate lowercase f evaluated at u times its derivative, it's really just capital F evaluated at u of x plus c. So what we're going to look at now are the steps that we'll use when doing a substitution, and then we'll look at one example, and we'll do a few more examples in class. So the first step is to choose a u and compute du. And the way to choose u is you want to look inside of the parentheses, the square root, a fraction, exponents, those kinds of things is where you're looking for a u. So the inside is the crucial thing because you're talking about undoing a chain rule. So after you do that, that's step one. Step two is to rewrite your integral using u and du. And then also evaluate. And the last thing you want to do is express your answer in terms of x. So those are our 3 steps, and we're going to use those 3 steps as we look at our first example. So here's our first example. We want to integrate 2x cosine of x squared. And if you notice, clearly, this is not one of the integrals that we have memorized. The integral of cosine of x we know, but we don't know the integral of 2x times cosine. This multiplication causes problems, and this thing on the inside causes problems. So hopefully also, I just kind of pointed it out, you'll notice the first thing is to find our u. And here, the u is on the inside, is this x squared. So it's inside parentheses, so that's going to be our u. And then if we look at du, dx, that's taking the derivative of that, we get 2x. And if you notice for all these substitution problems, what we'll generally do is write this with the dx on this side. So it's like taking that fraction and rewriting it 2x times dx. So we generally won't write this, we'll just write it with the dx already on the right-hand side, and that helps us as we move forward in our integral problem. So now we're going to use this x squared and 2x dx to rewrite this integral in terms of u. So the integral now, so first of all we'll look at the cosine part. So this part is really now just cosine of u, so that takes care of that. And then if we look at 2x dx, that's the stuff right here. So 2x dx is this part right here, so that just turns into our du. And we're really just integrating cosine of u du. And that integral we know to be sine of u, and then we'll have our plus c because it's an indefinite integral, there are no bounds. And then the last step is to write it replacing u with x squared, so this is sine of x squared plus c.